A keynote presentation also, but we have this panel session, and I believe there are one or two presentations also in this. And I think this is a very important session because in India there's special focus on 6G R&D, how India can play a bigger part in the whole 6G development process, in whole 6G ecosystem development, in whole 6G vision development, in whole 6G industry development. So I think this is very important and timely for us to at least have a review of what is going on. So we are starting this session with Mr. Paul Baming, Vice President, Head of Standards and Industry Initiatives at Ericsson. So maybe you'd like to start from here.
So what is a successful formula for making an impact on 6G globally? I think very important questions to try to think of and how to deal with that. So if we take next slide. First, one has to understand the background, why and what happened in the past, and why is it important to have it globally, to be global on this topic. And in this slide, one can see that there have been contenders to 3GPP systems in the past. It was 3GPP2. At its peak, it had 12% of the global market. It has 500 million subscribers, but that was very much subscale compared to the 3GPP systems that were 10 times bigger than that at that time, which we can see now is predominantly growing on the 3GPP system. So it's super important for any country in the world, regardless whether it's US, China, European country, or India for that matter, to be part of this process that we have been talking about the earlier days here on moving forward towards the IMT 2030 in ITU and the 6G systems that will be specified by 3GPP. So if you take the next slide, please. And this is the process. We have the ITU timelines in the bottom, with Dr. Olsen presenting very nicely exactly what needs to be done and when in the timelines going forward here. We have the relative timelines, as 3GPP has not decided fully exactly when they will start to do things and what they do, but they intend to be following the ITU deadlines and become to propose the technology in the end. So they will start with a study item in the release 19 time frame, and then they will continue with a study item on requirements, and then we will have a study item on technology in the release 20 timeline, and then they will have a work items, and then they will have the first version that will be dropped to ITU, and then at the end it will be continuous evolution as it has been with 4G and 5G as going forward here. And what's important in this, that obviously, even though 3GPP might not start talking the requirements until 2024, and then technology 25, 26, and 27, it's still important to have some bodies to feed in technology and concepts and ideas into this. And therefore, there's a super important happening at the moment in the world with all of these research activities that is going on. So if you take the next slide, please. So we have the research activities in the United States, predominantly through the Next Year Alliance. We have in Europe with the HEXA-X and the continuation of that, and a lot of national programs. We have the China with the IMT 2030 promotion groups. We have Japan with Beyond 5G Consortium. South Korea is continuing the 5G forum discussing 6G. And I'm happy to see that India is starting up its activities here. But what's super important is that this research not happen in isolation in order to be successful. So if you isolate yourself, you will not have the impact that you want to have. So you need to be inspired by the other regions, what they do, but you also need to inspire them. And therefore, you need to have a good and continuous exchange of ideas in this process on the research space going forward, so that we'll, when we enter the standardization phase, have an easier talking the same language, we have an understanding of what the requirements are, and we have an easier way then to select the technologies that is needed in order to fulfill the requirements going forward. Because eventually, all these research bodies or initiatives across the world will feed their results into the 3GPP and ITU process. That's illustrated on the next slide, if you say that, please. So that's 3GPP and ITU in the end. And the important thing is that it's not only the researchers, the academia that needs to be part of the research process, it is the industry that needs to be part of the research process, and the government. So there is all these three bodies that needs to be part in the same process, take part in the process, be international in the process, reach out, be inspired by other regions and countries on what can be done and what should not be done, and inspire other regions, because every region have enormous capabilities and potentials to make a good impact here if they are part of the process. If you are standing outside the process, you will not have any impact at all. So important to be in the process, academia, research, and industry and governments. So that's my recipe for success. Be part of the process, be international, discuss with everybody going forward. Thank you.
Next slide, please. So if we look at the global mobile traffic, it's expected to hit 5,000 plus exabytes per month in 2030. Similarly, the average data consumption per user per month is expected to go up to about 250 gigabytes. The total mobile broadband subscribers is also expected to go up to around 17.1 billion. And the M2M, machine-to-machine subscriptions, will go up to a whopping 97 billion. These are the expectations. So if we look at what the 5G networks are predominantly mobile-centric, but in 6G, the other device categories will be more predominant than the smartphones. So there's a need to support heterogeneous device types, the CPEs, the AR/VR devices, tablets, laptops, smartphones, wearables, connected vehicles, IoT devices, both industrial and civic, surveillance cameras, etc. Then there'll be a proliferation of multiple network types, such as public, private, enterprise, industrial wireless networks, application-specific, specialized networks. So which will make the B2B business model as a prominent business model for 6G compared to B2C business model for 5G. So there's also a need to address the sustainability and the energy consumption requirements to cater to the ITU SDG commitments. Now, with the use of higher frequency bands like the terahertz bands, the 6G networks can be much denser. So there's a need to reduce the OpEx for the operations and the maintenance of the networks. Similarly, there's a requirement of intelligence natively in the network architecture, so which is all over the connectivity fabric. The requirement is basically to offload the computation towards the edge nodes to improve the overall accuracy, prolong the battery life, and to have more lightweight devices by removing some of the embedded computing components. Another thing is that in the 6G, the networks are going to be overlay networks, so it's going to be a multiplicity of networks. So coming to, this is a spider chart basically which compares the KPIs between the 5G and the 6G. So if we look at the peak data rate, which is expected to go up 50-fold to about 1 Tbps, assuming that all that data is given from a wireless station to a single user. Then the user experience data rate, which is the 5th percentile of the cumulative distribution function, that is expected to go up to 1 Gbps. The air latency is expected to drop from 1 millisecond to 100 microseconds. The connection density is expected to go up by tenfold from 1 million devices per square kilometer to 10 million devices. As we know that there will be a host of M2M connections coming in 6G. The energy efficiency is also expected to go at least twofold, and the spectral efficiency similarly is expected to go twofold. There's going to be an more than 2 orders of magnitude improvement in terms of reliability, which is one of the key challenges of the networks of today. So if we look at the other diagram, basically for the 6G, it is expected to provide a ubiquitous coverage using satellite, aerial and terrestrial networks. So the satellite networks like LEOs and high altitude platforms to complement the networks, the terrestrial networks. So if we have a look, we have the regular terrestrial network in the urban areas, but for desert areas or for sea areas, we can see that the other modes are complementing that. So coming to the TSDSI 6G vision, basically there are 4 technology pillars. So the first one is ubiquitous, intelligent, mobile connected society, basically which requires the interoperability of networks based on different RATs, radio access technologies. That will be critical to enable a ubiquitous, intelligent, connected and compute environment. Then the networks need to be extremely flexible to cater to very high bandwidth applications such as holographic communications and digital twins to applications that consume extremely low bandwidths. Then to bridge the digital divide, we need to have composable networks that can be deployed in parts for specific services. Also, there needs to be a large variety of devices and device categories to bring down the total cost of ownership. Also, reduced cost for spectrum access through use of spectrum sharing and simultaneous spectrum use. Then energy efficiency to work in power-starved scenarios, and also to enhance the lifespan of self-powered devices. Then personalized and localized services, which include the use of edge nodes, distributed connectivity and compute environments, and native AI. Then native support for data ownerships and hierarchies. So as we understand that the network technology should consider intrinsic data hierarchies, which is, let's say, from personal data to enterprise or organizational data to national data, which is now considered national asset, and its security aspects. So then coming to the potential use cases and applications. So it could be enabling smart villages for, let's say, e-health, or for use of UAVs for precision farming. Then IoT devices for farm produce management, weather monitoring and warning system. Then Internet of AI, connected autonomous driving or assisted autonomous road transport, which covers platooning and increased safety. Industrial internet, tactile internet, high precision manufacturing. Then holographic type communication. So in addition to the frame rate and the resolution and color depth which is required in 2D, the hologram will require volumetric data such as tilt, angle, and position. So just as an example, to represent an object with images every zero point 0.3 degrees, a hologram with a 30-degree field of view and a tilt of 10 degrees will require an array of 3300 separate 2D images. So that is the volume of data required for hologram. Similarly, the extended reality devices with a 360-degree field of view will need a much higher data throughput. For example, up to about 1.6 gigabits per device. Similarly, 16K ultra-high displays can require something like 0.9 Gbps throughput. Then immersive interactive experience, then Internet of Senses, where apart from sight and hearing, you also make use of smell and taste senses to give a more holistic experience to the users. Then Internet of Tags for asset tracking, remote e-healthcare, large-scale twins, digital twins, to basically control the physical systems through modeling in the virtual space, enhanced surveillance for crime control, ubiquitous connectivity and compute experience, comprehensive AI in wireless, which is local AI, joint AI, and end-to-end AI, to optimize the overall system performance. And so here this shows basically a digital replica to bridge the real and the virtual world. And another image here shows a truly immersive extended reality experience. Then coming to the key R&D field, 6G R&D fields and the technologies. So for enhancing the radio interface capability, so new waveforms for sub-terahertz communications, like the orthogonal time frequency and space, or optical angular momentum, terahertz communications, visible light communications, advanced modulation coding and multi-axis schemes, massive antenna and wideband beamforming, so cell-free MIMO as an extension to coordinated multipoint, extreme MIMO, co-frequency, co-time, full duplex communications, in-band full duplex communications, multiple physical dimension transmission, interference cancellation techniques for self-interference and interbeam interference, non-orthogonal multiple access, hybrid terahertz optical wireless communication link. Then for enhancing the radio network performance, full duplex radio, smart antennas, new architecture to support new operation and business models, support of resilient and soft network and guaranteed QoS, digital twin networking, support for convergence of communication, computing and data, intelligent network and services. Then enhanced mobile network for non-terrestrial networks to support integration of terrestrial and non-terrestrial networks. And support of native security, intelligent reflective services for improved indoor coverage of millimeter and terahertz links, and to mitigate the blockage in sub-terahertz communication systems. Then adaptive radio interface technologies like the cognitive radio, AI-assisted protocol design, native AI-assisted air interface, network architecture designed for layer 1 PHY, configurable baseband distributed AI computing, intelligent framework for application AI and RAN and core, hybrid networking with RRH and intelligent reflective surfaces for better interference control and network coverage, with less transmit power controlled by a set of coordinating RAN elements. And for enhanced service coverage, interconnect integrated solutions with aerial and other non-terrestrial networks, and light communication. And enhanced privacy and security. So blockchain-based distributed ledger, quantum communications, including quantum key distribution, quantum clock synchronization, quantum random number generation and computing, hardware-based secure environment, security for artificial intelligence systems. Then enhanced adaptability and sustainability. So the technologies are zero energy communications and split computing. So with that, I think I come to the end of my presentation. Thank you.
Thank you very much. I'm told that Shri Abdul Qayyum is coming shortly, but we will continue. Our next panelist is Dr. Sandil Devar from 5G India Forum. Over to you, Sandil.
Good afternoon, and probably we missed a tea break, so I'll try to be very short, and we'll jump to the panel discussion to be more interactive. Yes, so we heard from Per about the process of 3GPP and ITU, how they are aligned, or at least they are planning to contribute towards the 6G development. Whereas from India, around December 2021, probably exactly 1 year back, forum was set up by the Department of Telecom called the Technology Innovation Group for 6G. And the idea was to publish India's 6G vision probably mid of this year. So there was some task forces created, different task forces to set up what is that we are looking for from a standardization roadmap. What should we do to be seen as a leader in 6G? And what are some activities we need to do in the spectrum areas? What are some areas we need to, when we want to develop multi-platforms? So there are multiple task forces that were created. And we are excited that we were given an opportunity to contribute to all those task forces. So I would like to share some inputs that we shared. And after once the Department of Telecom discloses or publishes what the vision for 6G is, the next step would be to start working towards that vision. Yeah, thank you. Yeah, so we have been part of some of the sessions yesterday also. So probably this may not add much information to these slides. So, but we have been very active in the task forces where we gave some thoughts. So we'll walk through that. So these are the task forces that was set up under the 6G TIG group. So there was one group which was specifically focused on financing R&D activities. I think it's a very important task force that was set up to facilitate, or how do we identify, how do we invest into those R&D bodies or academia or startups who want to start investing into 6G topics, and how do they contribute to the development of 6G. So that was a task force that was set up. And there are other task forces where we have been very active is on the international standards contribution. The idea was, how do we contribute to the standards by the time 3GPP starts working or ITU starts working towards the 6G development? How are we prepared towards it? And then we had a group on spectrum policy, Professor Abhay Karandikar from IIT Kanpur. He was supposed to be here in yesterday's 6G spectrum, 6G system strategy group. So we would have had more information on that task force also. So given this 4+2 task forces, let's look at one of the recommendations that has come in principle, what exactly the task force recommends. The idea is to, once we have the vision set up, probably we have already seen a lot of white papers coming up from different 6G groups, HexaX, NextG Alliance, probably Vinod from Qualcomm will also share some thoughts. The idea is, once the vision is set up, next is to see that how do we develop our technology or R&D focused into achieving those vision. And then what part of those R&D activities actually feeds into standards. Some may be an application layer activities. So some goes into standards, some does not even need standardization effect. So we need to categorize those and then we start working towards it. So the idea is to, before we start developing into the standardization phase, we need to have all the ecosystem players to sit together and discuss about this. So one of the recommendations that came up from the TIG 6G document, I would say the draft document which is not yet there, was about having all the stakeholders, including the R&D partners, academia, hyperscalers, because we see that it's not only about radio, but it will always be other applications will also be playing an important role. So all of them working together to create the technology development towards 6G. The other aspect was to prioritize where the research should be focused on, so that by the time when the standardization activity happens at ITU or 3GPP, we are ready with the inputs from administrations or from these startups or academia, wherever they go and participate into those forums. And then the other idea that we also looked into the entire timeline all the way from now to 2030 is also to see that what is the time where we should be prepared to start doing early trials also, or building test beds by the time frame when the specs are available. So we had a longer look all the way till 2030, and we have some rough ideas that we discussed within the 5GF members. And before we jump into the timeline, what is important is to see when 3GPP starts working into study items or work items, before there are a lot of preparation activity that goes before even 3GPP starts working. So this is one of the input that we had discussed within the task force is about the standardization process. Is that even we start talking about study items, we need to see what exactly are we looking at, what is an end-to-end picture that we are looking at from an application that we want 6G to deliver. And to do that, the idea is to have a concept, multiple R&D organizations are, welcome Abdul Kaim ji. So within different bodies, they start looking into some initial technology research in those areas. And then the like-minded groups, academic research, companies, they talk to each other, they start exploring those areas and see that what is the right time we should start building input towards 3GPP. When 3GPP starts looking at the feasibility of such things, they call it as study items. So before the study item activity starts at 3GPP, we start preparing those inputs. And one of the benefits that I think in the per Beming slide was about when we started moving from 2G to 5G, we saw that there was 3GPP was one of the technology which is globally adopted, and then we see large adoption of single standard. That's because of the scale that having a one global standard gives up. And the 3GPP itself has more than 800 plus members who actually contribute in building the specifications. So 3GPP, the other plus point that why we see 3GPP success is because of the standards being developed in an open manner. Every meeting, at the end of the meeting, you have the documents output, the input that goes into 3GPP is publicly available. The standards are openly available for anyone to adopt, start implement it, and to also even contribute. Yes. So we are at a stage where once the 6G vision is published, probably we will see a dedicated activity that will happen within India to include these inputs coming from different stakeholders, and we'll start prioritizing those activities. This is a rough sketch of idea that we have been discussing, that when we see we are here around 2022, probably it's setting up some initial stakeholders meeting, including all the stakeholders in India. And then we also need to start doing a cooperation between other 6G programs. In one of the slides, the earlier speaker also showed that Europe, US, China and Japan, already a lot of 6G programs have started. I think if we start doing now, we need to start actually collaborating with them and see that where they are and how do we complement those research activities. So we have another 2 to 3 years where we could start doing research focus in those areas and then start preparing and see whether we are preparing towards the performance requirements what ITU is setting up, what 3GPP is expecting. And similarly, when you go towards the end of the time frame where we will see that we had a 5G HLF forum that was created, and that was a very important step that was taken which helped India to take decisions to launch 5G auction, the trials and everything. I think by the time 2030 when we have the standards available, we also need to have a similar framework which accelerates availability of launch and trials of 6G in India around the same time. So we'll be along with other countries who are launching 6G as soon as the standards are available. So this is a rough idea of the timeline that we had discussed and shared with the committees. Probably we can take more questions and see how we can deliberate more. Thank you very much.
Thank you, Sandil. And I would like to take the opportunity to welcome Shri Abdul Qayyum ji, Deputy Director General, 6G at the Telecom Engineering Center of the DOT. So, welcome. Uh, what we've done is we have actually started these speakers. So, let me complete this and then I'll hand it over to you to do some Q&A. So, we have now next on the panel Dr. Vinosh James. Vinosh, you may like to share your thoughts?
We missed several buses, the 4G bus, the 5G bus. We are almost there in getting it next, right? So what is this missing means and what is the implication, right? So for example, I have been closely tracking the North American program, the NGA program, and the European program. So what we were able to establish it in the North Americas is basically to create policy frameworks, identify strengths and weaknesses in the region, and then identify those topics in which we need government support, meaning the US government support, to invest on long-term research. So it actually builds the skill set. It builds skill set within the industry. It actually brings in the universities to come into collaboration and work on cutting-edge technologies. And of course, that common thing, right, that I want to establish North America as the central to 6G or Europe as the central to 6G. That's what is going to happen everywhere. India will be no exception. But the catch-up time will considerably shrink if we are actually going slow, right? So one of the efforts we saw in that direction is the TIG 6G, which is actually trying to put together a framework and go in that particular direction. But then we need to set it up, we need to put it into action, and then have a lot of these strengths and weaknesses to be identified, right? So let's take it for a fact, right? China is leading. Europe is stepping up, funding a lot for research and doing work. North America, because of the companies, the big companies established in there, they are doing in-house research. But there is always opportunity for every region to tap. For example, India, its strength is in the services sector. And if you are looking into how 6G is envisioned to be, it's about, as my colleague from CDOT also mentioned, the intelligence edge is the theme. You are trying to make it more immersive, yes, but the immersiveness will come because you are actually having services which actually enable it. And that's in software, right? And we have a huge lot of software which is actually manufactured in here and then also sent to the other parts of the world. But then we need to identify what is it, because we need to prioritize research so that, a team dedicatedly or focusedly works on it and delivers in time so that the global standards, when they are made, we are right in time to provide inputs. Right? Anything late is obviously waste. So you have to be in time to actually get it to the table, make it variable, and that's the, where we as companies are willing to participate in creating that program, right? So we have been working with multiple agencies. So for example, Vikram, through him, through the CAI, through the 5G India Forum, through ITU-APT Foundation, through Broadband India Forum. We have also got a lot of engagements with universities like the IITs on a bilateral basis. A lot of these things actually go. What is missing is that synergy. So we need to bring in that synergy into the table so that there is a dedicated team of effort running it, right? So we look forward to see, how this platform will actually enable move us in that direction. Back to you.
Next, perhaps may I request Professor Brajesh Lal. Welcome, sir. Please provide your views.
Hi, good evening, everyone. So, for the first time, even though we started, maybe we're only a year late, it appears, as compared to some other countries. So, for once, research can play a role. So, we can start from requirement analysis. But as James Vinod correctly pointed out, synergy is important. It isn't about silos of research, because 10 years of which only 8 are left is not a very long time. So people have to get together right now. They don't have to sort of put their house in order and then start speaking to each other and putting things together. It has to be more defined. People have to get together, talk of what they want to deliver, and then go back to their drawing board and do whatever little applied research still needs to be done to make some of those things happen. So the timing might be a little late, but for most practical purposes, it is right. So synergy is the first thing. We should all be talking to each other, and we should be understanding how we can come together and participate. So that's the first thing. The second thing that we should also be a little mindful of is what are the requirements that we are trying to address. While it's very easy to push tech that is available, it's very easy to be buoyed or to be excited about some of the developments other people are doing. We should not lose sight of India-specific requirements. This is something that we should take an opportunity to incorporate very, very clearly in these early discussions that the stakeholders are going to have over the next few months. So the first thing I said was synergy. The second thing was being very, very mindful of what our actual requirements are, the kind that rest of the world might not look at all that carefully. You know, there's talk of remote, but remote might mean different things to different economies and different markets. So what is remote for India? How is it that it can be addressed? And finally, what we should be doing is that this again is related to synergy. Academia can play a role in helping some of the startups. There might be a need for an ecosystem where the smaller players, especially with this increased softwareization of communication solutions, especially with this advent of AI, ML, making things possibly a little easier, and a lot of heavy lifting being done by 5G, because 6G would also be about a degree of consolidation. It's nice to talk about all the new features, but one thing that 6G will achieve is that some of the difficult challenges that we set out to achieve as part of 5G will be consolidated in 6G. Now, these are areas where the smaller companies in the ecosystem can also play a role, and there should be a clear thought given to making it possible for them to be strong contributors, be it in the space of new research, ideas, or translation of those research ideas into working engineering solutions. So this is primarily what I as a person from academia and research space feel can be done to make this happen differently. Thank you.
Thank you very much. I think very good perspective. And may I now hand over to Shri Abdul Qayyum ji for your initial remarks, and there are some questions that perhaps you may ask the panel to go ahead with that. So over to you. Thank you.
So let me thank ITU-APT for inviting me to this August forum. And I would like to tell you what government is doing. I think many of us are already on some of the forums constituted by the Department of Telecommunication. So how I take what we are doing, this is really very, very different what we have been doing so far. So first of all, we are not working in silos. Now we know our task very clearly, what Department of Telecommunication is to do, what Department of Science and Technology is to do, what MIT is to do. So there is a very clarity, and there is a internal coordination on that. So earlier time there used to be a lot of overlaps, and but now you will find in days to come that interministerial discussions are leading to tangible results. So, for example, if you are planning to some product, some research, so we are thinking, okay, if this research comes, which is the industry which is going to use? And then if the industry is identified, then who will provide the market access to the industry? So forward and backward, both the way we are thinking about it. So we will, we are trying to ensure that if there is any product from comes which and it should have a market access first of all in India, so that only after having tested the products in India they will be able to sell it abroad. So earlier, if if a company somehow produces something, it was finding very difficult to get a foothold to get their product tested. So it is a very synchronized efforts. It may not be visible to the many people, but government is taking steps in a very right direction. So as regard to the 6G, for example, we are having regularly, almost every week we are having 2 to 3 meetings, how we are going to move. So, for example, in Tera's communication, we are going to have a forum in maybe in a month or so, where researchers can present their ideas, and where the startups or the companies who can develop those ideas into product. So the research is not going to be in an isolated direction. We are going to write the requirement for the research. This was not there earlier. The research proposal used to come to the ministry and it will be get approved without any clear directions. So now, so this is going to change. We are going to write requirements. This is the requirement. Now approach us for the fund for those to meet those requirements. So end to end, it will not just start at the research. It is going to find some product. So. So that kind of clarity is there in the department, and hopefully in next 2-3 months time we will be having many number of missions on which we will be actually working and collaborating with the academia and the industry. So and I really am very happy that ITU-APT is working on the starting point. We had a, on 18th of November, we had meeting with the academia. So the first question academia asked, which band you are targeting? And we really had no answer. So if you want to develop, if you want to do some research, we have to provide them something that, okay, you work on this. So otherwise, how they are going to stand wildly at what band they should start? So that kind of indication perhaps should be coming from this forum. You had 2 days discussion, and hopefully some recommendation will be coming from this. And then those recommendation, if it is, of course, it should come to the DOT. We should be sharing those recommendation to our academia and see their feedback on that what are the things we should be doing it. And I requested Anken also yesterday that ITU actually for country like us, we are not having many developed industries who are conducting sharing studies, right? So, or they have the result of sharing studies. So ITUR should be actually taking the lead, so that we have results early, much early than what he was suggesting, that first it will be approved as an agenda, then only ITUR will be taking up the studies. So if the study takes 3 or 4 years of time, what India will be doing? At least our researchers will be, far more in disadvantaged position. So this forum should actually recommend what are the things that we should immediately start, and ITU also conducts a study and provides the early result to the India. So, so that is actually all from me, and now I would be actually asking few of my questions to the expert. The question which actually I used to receive, people meet me and pose a lot of questions, and I don't have the answers. So this question is to Mr. Parbening and Qualcomm. See, we are actually talking more about AI in everything. So, is it really necessary that AI should be in everything, in every aspect, when we are simultaneously considering sustainability, right? Is that the device shouldn't be consuming more power, right? So how this is going to balance with the performance and that energy efficiency or sustainability, whatever we may call, how the Qualcomm is approaching to this to meeting this both. Yeah.
Okay, then I start. I agree that needs to be a balance between where you put AI and what you use AI for, and it can be done on many aspects, on many topics. It can be used for optimizing the total network by taking all the inputs from all cells that you have and make better decisions on what frequency bands to use in which area and what how much power output you should have in what spectrum and what cell. And this is a super difficult puzzle for a human person to do, so that I think is very natural for a machine and an AI algorithm to run that, to optimize the network slowly. Then if you then goes from that holistic network level and deep down, there is still research and talks and even standardization work on making AI radio interface solutions that will change over time. That is, to me, a little bit more futuristic and may also be consuming a bit more power, because the algorithm and the learnings needs to be done fairly far out in the network, and therefore will consume more power. So that is more futuristic to me, but I still think that there could be something into it, since there are always algorithms anyway that needs to do a lot of computational power in the device and in the base stations right far out. So there will be a lot of AI. Exactly what, I think we will have to see a balance on going forward.
I'll cover it from the device perspective. Okay, so I think what is AI in a device is like this very often confused terminology, because it's not like a always running program. It's just an agent, right? I'll give you a small example on how AI is actually helping in the sustainability. So if you look into a handset, there are like 6 or 7 different radios running. There is Bluetooth, there is cellular on different bands, and then you have Wi-Fi, NFC, several of those stuff. If I can actually run a small agent and then switch off those radios which are not used and then keep only those monitoring things active, I can save up to 30-40% power. That is level 1 of sustainability, just sensing radios and then trying to do something. The next level is, can I actually reuse chip cycles, or can I use the same silicon into trying to doing multiple things using the same modules? That brings in other level of intelligence, right? So AI is going to improve, there is no doubt. I think to what level, and will it be like a fundamental change? That is something we will wait and see over the 8 years. But yes, even during the 5G advanced timeline, we will see a lot of these savings coming in because of an intelligence agent running in the device. You call it AI, you call it ML, you call it something else, that's different. But yes, the gains are proven already.
Thank you.
Just to comment, at a slightly higher level, when we look at AI, ML, we think of it either as being good or as being bad. But let's focus on the second word in each of these acronyms. So in AI, I stands for intelligence, and in machine learning, L stands for learning. So intelligence and learning, if used correctly, will certainly lead to gains in the long run. So we should not get carried away with the debate that's going on about AI being good or it being bad. We should rather focus on the fact that intelligence and learning are important things. They are useful and they are good in the long run. Artificial and machine, where are they going to end up is something that might change, but intelligence and learning is going to stay in the deployments and the offerings of the future.
Thank you, Professor. So now next question is to Mr. Anurag Gupta. So as we all know that C.4G POC in BSNL network has been successful, and we will have 4G deployed for more than 1 lakh base stations soon, and 5G, C.5G I will say is going to be deployed by perhaps next July or August. You have the targets. So what is the the next that you will be asked to do a lot of things in 6G? So what is the key research that as an organization C.DOT has identified, and in a broader perspective, what you think others should be doing in India?
Thank you. So I think some of the key things related to 6G with respect to increasing the overall, supporting the additional data requirements, as I said, was let's say communications, terahertz communications or visible light communications, and massive antenna and wideband beamforming. So I think from C.DOT perspective, we will be focusing on one, the integration of multiple networks, which is the wireless, the wireline, the ubiquitous connectivity, so to say. So that is because we've been working in the area of different networks. So that is one thing, and also on the RAN side, in terms of more advanced schemes, whether it is cell-free MIMO or extreme MIMO. So those things, so we are going to concentrate on. And also convergence of compute and communications. That is another thing. And also we'll be working on multiplicity or like overlay networks, so to say the terrestrial and the high altitude platform networks, and maybe going forward sometime even satellite networks. I think that is going to be the focus areas.
Thank you, Chandra. Now the next question is to Professor Lal and Erickson. So again, in your opinion, what should be the bands for 6G? And no, you and Erickson both.
Brilliant. So
Requesting answer from both. So you
So,
will be
yeah.
actually covering the academia thought process, and Erickson industry.
yeah, see, from the academia and research perspective, this is not the right question to ask, because academia would want the entire band to be available for everything and come up with ways to handle it, right? I think maybe Erickson takes it first, and then maybe I can comment on their line of thought.
All right, then I start then. I think we need many types of bands. We need coverage bands. We need bands that we can have good coverage out in the rural areas. Of course, the bands need to provide capacity and performance bit rates to end users. So therefore it is difficult to find those bands in the very low bands. But for us it's important to expand on the already identified bands for the mobile, on the mid bands. Primarily we are looking into the range. Don't say that we should have everything there, but in the range between 7 gigahertz to 24 gigahertz. It's good band to find there. We would like to think that you should have possibility to get maybe 1 gigahertz per operator in that segment. So if it's 3 operators, it's 3 gigahertz of that band width that would be required for 6G going forward. Then of course that will be complemented with already allocated millimeter wave bands by ITU, and then also these sub-terahertz bands. But we should note that the sub-terahertz bands are not that useful for the wide area coverage. So it's more complementary for indoor and those aspects. And of course, it is a balance act here, finding the right spectrum. And we don't expect that every country in the world will have a fully global spectrum band here. So there will be some challenges for the device side, I would say. Our friends Qualcomm will have a task to accommodate the global spectrum situation that will be coming out of the 60, as we think.
Thank you, Professor Lal.
Your first comment, of course, is that spectrum which should be used is something that, well, a decision that government will not be able to deflect onto anybody else. Eventually it will reside with the government. But I think, as we've already understood that different bands serve different purposes, the problem is not which band serves what purpose. The problem is what services, or rather what technology should they be used for. I look at it slightly differently. For me, we should rather be addressing the question that when 2 or more different technologies are using the same band, for example, the satellite and the terrestrial interference that's happening, is there a way to handle it so that both can coexist in a manner possible? So I think that is one thing that maybe outside the forum, the ambit of 6G, is something that the DOT should look at. How can it make sure that the bands become available to more than one technology simultaneously without impeding the other one? Cognitive radio became quite popular a few years ago, and it still hasn't lived up to its potential. So maybe there's an opportunity there. Thank you.
Thank you, Professor Lal. Actually, in my opening remark itself, actually I had requested ITU-R to do the study where without replacing the other use cases or users, we can have some kind of technology which uses irrespective of the users, right? So that will be the very interesting things, because moving some existing user to any other band becomes very challenging and difficult.
Can I just complement just one small part, right? So if you were there when Ravi Gandhi was speaking yesterday morning during the introduction section, right? I'll just try to put it blunt. He's like saying, you know, don't tell me this spectrum is for that, that spectrum is for that, for a certain service and certain other service. You give us the spectrum. We will run a technology on top of it where they will coexist and work, right? So in addition to harmonizing these bands, we should also think about harmonizing technology so that, you know, the same technology can be used for a slightly different service. That work has already started, right? For example, NTN has started in 3GPP. 5G broadcast is there in 3GPP. So the moment you start reusing the same technology for different services, the coexistence problem goes away.
Yes.
And you will be able to find even more spectrum resources to basically support that service. So that's one area, you know, where we can actually focus on during the standardization effort in doing this.
So that is the, you know, very good point which has emerged, that we should be looking for a technology which can handle the challenges posed by different users. Right. So that will be really a good thing to happen.
Yeah, thanks. Maybe this is one more additional point, very good point Professor Brijesh Lal pointed out, right? So it was very sincere answer saying, I'm not the right person to say which band for 6G. But then if you tell me what band, what we are looking at, and I want to take a cue from what Per just mentioned is about, we are looking at a channel of the order of 1 gigahertz per operator. So I think we should look at saying if a single operator has a single carrier of 1 gigahertz of a channel bandwidth, what is the kind of research focus needed? What waveforms are needed to have a single carrier that can span entire 1 gigahertz of bandwidth? I think that are some cues that we can deliberate and see that can we focus research on those areas. That will be some good points. Yeah, thank you.
Yeah.
Right. So, I mean, if we just build on what Senthil just now said, if we are talking of 1 gigahertz per operator, and I'm just assuming minimum 5 or 6 operators, that means we are looking for some kind of a contiguous spectrum of 5 to 6 gigahertz, which under the present scenario, unless we come up with some other technology solutions, would all be coming in the terahertz kind of band. So you won't find that kind of a contiguous spectrum in the lower bands. But I have a slightly different view here. 1 gigahertz and those are very critical and maybe they may be required. But I think 6G will continue to need lower frequency bands. They will continue to need certain services which do not require that high bandwidth. They could still work on maybe 100 megahertz channels or maybe 200 megahertz channels. And for those channels, I think we still need to find additional spectrum. And those could possibly come from whatever spectrum we have already been talking about. Let's say 600 megahertz band, and let's say there's a virgin 500 megahertz band available in 4.4 to 4.9, which is today unused. So let's see, we build upon all the three, the lower band, the mid band, the high band, and of course the terahertz band. So when we talk about 6G, we should not focus on only talking about the terahertz band. We have to look at all bands, and the research has to, and I fully agree with Professor Lal, that research has to focus on, here is the band, here are the services that are supposed to run, how can we make them run together, how can we make them compatible with each other, and I give an example of CBRS in US, for example. That's one band in the 3.5 gigahertz band, 3.7 gigahertz band. They are running the IMT in that band, they are running satellite services in band, and they are running the unlicensed broadband service in that band. All three are running just by using technology. I think we in India need to look at what kind of technologies we can develop to make sure that the existing bands can be used in a better way. Thank you.
Thank you, Bhatia sir. Yes.
Hello? Yeah, fine. My name is Paul Dayanathy. I just want to ask Anurag Gupta, in your presentation, you had made NOMA as a one acronym in your 6G. Is NOMA is going to be a 6G technology or it will be a 5G advanced technology? Because non-orthogonal multiple access will as far as I have submitted 2-3 IEEE paper on that, which will be made available when large number of users are using 5G. The power becomes a constraint, and based on that now, because I had 2-3 papers I had submitted on NOMA, and you had told in the 6G in your presentation that NOMA will also be coming as one of the acronym in the 6G. So will it fall on 5G advanced or in 6G? And also another thing, you had also made a statement on OFTS, orthogonal frequency, this one, OTFS, sorry, and that will be the modulation technique on that particular subject. So could you throw light on that?
So basically, the 6G networks are going to be like more enhanced and flexible than even our 5G networks. So they'll be basically like network of networks. and to cater to a very large, diverse set of requirements. Now, NOMA, as you rightly said, basically the complete set of frequency and time is made available to all the users. And the power is what is then defining the usage of multiple users. So basically, in 6G, as the requirements are so diverse, like I think there was this question also that which bands to use. So in 6G, when we are talking about not just smartphones, we are talking about a multiplicity of devices. We are talking about a multiplicity of requirements. Then apart from terrestrial networks, we are talking about aerial and satellite networks. So basically, that is why I just mentioned that NOMA is also one of the candidate technologies, because it's not that we are doing away with any of the existing networks. When we talk about 6G, it's basically whatever the existing networks could not deliver. As an increment, as an overlay, as I said, we could have those requirements getting met by the newer networks. So that is the concept of 6G. That is how this point is.
So, this question is to anyone of you, from the audience also. What are the suggestions that that Indian R&D and global R&D can come together? Well, I will share my experience that we are working on is standardization of QKD, quantum key distribution system, and I approached to a number of European universities. Hello. European universities, but we are actually not getting any proper answer. And only one of the university replied that, okay, you have to approach to the European Union. We have been funded by them and we cannot really discuss on these matters. So that is one of my experience. So how do you think that at industry level, this kind of collaboration, we talk about the collaboration, but is it really working? And what are your thoughts, any of you who can have some suggestion or answer to it?
Yeah, so if you, the way I look at it is that for 6G to really be India to take a lead in the global ecosystem, we need to also focus on devices. See, big system solution, all those core technologies are being developed already by multinational. We can also play our part and be part of the ecosystem. But where we can take a lead, and maybe everybody looking at China plus one strategy today for devices, India could be one of the hub and supplier for tomorrow, day after. In fact, I think Professor Paul Rod mentioned in one of this thing, even for 5G, devices are yet to evolve. So maybe we can even play a role in focusing on developing the devices. So even if the core technology has been developed, doesn't matter. Can we focus on devices of 5G and continue that journey to the 6G devices, all these immersive experiences and all that we are talking about? We are going to need a lot of devices, and that's where our startup ecosystem, our premier institutions, and the senior individual technologists can contribute to bringing this to the fore. Make in India is not about assembling in India. That is what is happening today. Design in India, conceived in India, designed in India, made in India for the world. That is the kind of paradigm we need to move. And that way, even if we may miss on a few aspects on the core R&D in the 6G research, because we still are evolving, getting into that, matching the global ecosystem on that core research. But at least on this side, we can start taking lead in a very comprehensive manner in the next 5 to 7 years. That's my personal way of looking at it.
Yeah, my answer to your question, sir, if you take a simple example, I hope you will be aware of Cohere Technology, a startup company in US, has come up with an innovative solution for in the development of Open RAN, where the RIC is a one module in Open RAN, which is RAN intelligent control, where maximum full potential of the spectrum is being made. And we have Vodafone, we have Nokia, we have Ericsson, all these company MNCs. But a startup company, Cohere Technology, has done that. So when such things can happen from a startup company from US has done it. Now Vodafone UK has handshaked with that company, and they are using their algorithm and all this stuff in the Open RAN, and they are already marketing in UK. Vodafone UK is doing it. So same thing can happen in India. Startup can do that in handshake with IITs. It's not that or with some of the CDOT or other companies like Samsung and all this stuff. So it's not that a startup from US only should do it. You get what I'm trying to convey.
Yeah, thank you very much.
Yeah.
So-
Because Cohere is a technology which has done a multi-user MIMO with full potentiality, because spectrum is a very rare resource and very costly resource. And they are using that. I think Mr. Brijesh Lal also knows about it. And VMware is he's a BTech from IIT Bombay. He's a friend of me. He has made a presentation. He's a director of VMware. I've shared that presentation today to your senior director of Qualcomm. I don't know, Jitendra Singh, is there? Another person now, see, whom I met, he came in the morning, he spoke. I had given that presentation to him to understand, to go through it, and why Qualcomm can tie up with some startup company and develop such things.
Thank you.
I'm talking about India-based Qualcomm, not foreign, UK-based or US-based.
Kayum sir.
Forget about all those things. I'm always be Indian, buy Indian. I don't go above that.
Chairman, on the QKD question, I think the problem is we don't have an institutional framework yet. And the research is actually happening within those institutions we saw in first, I think fourth slide or something. So those are funded projects by those administrations, and they are willing to work with sister organizations of the same format. And that's what I meant that, we haven't put together that framework yet. And that framework is not just this, even sustainability, topics like energy efficient and other things will only be shared under those paradigms, because these are assets.
So, thank you very much. Actually, my experience is much deeper. We have bilateral agreement with almost all the European states, right? And this question I have raised to all the delegates I met, right? So they will take the questions, but actually it has not materialized. So we lack framework, I agree, but who is the framework? Telecom Engineering Center is the standardization. It is the job. It is their job. When we are writing them, we are the body who will be writing this standard. And now the problem, I'll tell you. When we bring this under the MTCT, in mandatory testing, then the European will come running, I'll tell you. They come running. Okay, we were not consulted. We don't know. Our company will not be able to comply. We need 2 years of time for adoption. Right? It is not like that. Then how they know our address? When we make it mandatory, then they know our address. And before that, there is no framework. So that is actually not right. I will say people are secretive about many things, and they do not really share many of the things which are required in the standardization process. So, it is good that we work more closer with all other bodies. That is why our intellectual level increases, and we get a better C energy. Right? That is expectation. But how to get that is that we should work. Yeah, Mr.
Kayum sir, it's very simple. You have to put money on the table. Right. So all the countries, there was a slide about different countries who are actively working for 6G research. There's a dedicated budget which has been put aside, and in the institutional framework, the good news is that the government agencies and industry is together. Now, if TEC or CDOT, you want to be in a space, you have to have the money with you. So the good part is that we see as part of the Telecom Development Fund, there is some scope of providing money. Now the question is, when will you decide and when will you give that money? Right? You can keep asking Indo-Swedish ICT Forum, Indo-Japan, Indo-US. Unless you are talking equal to equal, rest, I've been a member of many of these. So, that the respect comes when you're on a similar equal platform. The second part is Indian engineers in Bangalore, the second biggest R&D outfit outside the home country, we have the skill sets, the manpower, but you know, they're working because they're on a different, salary structure. So what prevents Government of India or TEC or CDOT to match salary to salary? You'll get the people work for on that. And it will be Indian IPR. So the question is, any technology, you have to push it with adequate funds, because it is what you call, it is an asset, right? Just by asking for it, it will not work. Thank you.
So the outcome from this discussion is that we should have money on the table, and then only we should discuss anything. So, good news is that soon we will get the money. So, for example, for quantum communication, though we are soon going to get money, and the institution will, will get lot of funds. And I'll tell you, particularly in quantum communication, I have traveled to IITs, many IITs and research institutions. They are having good fund and good laboratories, good setup for quantum communication. And I think for 6G also, we will be aggressively funding and TTDF, the Technology Development Fund, has been created solely for this purpose, so that at least DOT is not depending upon the government for sanction of something. So this money belongs to Department of Telecommunication, and we will be at the liberty to spend on the right projects. So, yeah.
Thank you. Thank you very much indeed, sir. I would request our session chair, Mr. Abdul, to kindly do the honors of presenting mementos to our eminent speakers. As a token of gratitude, we present to Mr. Per Birming. Thank you, sir, for that wonderful keynote presentation we had from you. To Mr. Anurag Gupta, Group Leader 5G CDOT. Thank you once again, sir, for the presentation. We present to Dr. Vinosh James. And to Professor Brajesh Lal. With that, we thank Mr. Abdul for kindly doing the honors. I would now request Mr. Bharat Bhatia to do the honors of presenting a memento to our chair, Mr. Abdul Qayyum. Thank you very much indeed. I would now request Mr. Bhatia for the closing remarks.
Thank you very much, Abdulji, for very well conducting this session. And with this, we come to the close of our 2-day, very active, very hectic, very busy conference on spectrum management. Yesterday when we started, we had almost overflowing room with 300 plus participants. And even today, at the end of the second day, we still have quite a large number of participants and very, very senior delegates. I'm really thankful to all the participants, and in particular to the people who have traveled from all over the world. Hakan Olsen is here, Babaming is here, and we had Masanori Kondo-san, and many more. And really people have taken time and effort to prepare the presentations, to deliver the presentation, to actively get involved and be a part of this whole discussion, this 2-day discussion on really creating awareness of what the spectrum issues are. I mean, there are different positions different stakeholders have, But I think it was great at least to listen to all sides of the position. It was great to see kind of debates, that kind of discussions that we had, kind of presentations we had, all kinds of issues, whether it was on the 4G or 5G or 6G or Wi-Fi or anything else, on the vision, on the spectrum, on the technology, on the roadmap, on where are we going from? Going from here. I mean, it was really, really something. So I'm really thankful to all the speakers, all the participants. And really, I also would like to take this opportunity to thank our organizing team. Please join your hands for Ms. Arush here and Ashish. There is Ashish here. These people have worked many, many days and nights, and Joel here. Soni ji is here, been part of our team, and Mr. Bajpayee somewhere here. There he is at the end. So really this team has worked together for many days to put together an event like this with all your cooperation. Thank you our sponsors, Meta, Qualcomm, 5GIF, GSA, and all our partner organizations that you see, so many of them here. And really, really everybody helped together in putting this together. I'm also announcing right now that we would have a similar conference in November next year. That will be the third Spectrum Management Conference. It will happen about 3 weeks or 2 to 3 weeks before the World Radio Conference that is happening in Dubai. We will schedule a date depending on the other arrangements, and we will come back to you on this. We are also going to have some other events from now. Particularly this one event that I'm currently working on is on the 6G vision, because I think the ITU will finish in this meeting in January and about the vision recommendations, hopefully. And after that, at least to understand what that recommendation means to us and what we can do in India, we might do something else in around March timeframe, before the APG, etc. So thank you very much. I think there is tea and coffee. We missed the break earlier. There's tea and coffee, and with that, we close this session. Thank you very much.
Thank you very much indeed. Ladies and gentlemen, before we move for the tea and coffee, may I invite all our speakers and the organizers on the stage for a group photograph. All the speakers present in the audience and the organizers, everybody to kindly join us on the stage for a group photograph. Thank you. And with that, ladies and gentlemen, we have come to the close of Second India Spectrum Management Conference. I once again take this opportunity to thank